Hello all, welcome to the fourth session on the introduction to functions. In this episode, we are going to talk about the system of linear equations. Now that we know what's a linear function, what is a linear equation, let's understand what is a system of linear equations. A system of linear equations is nothing but essentially a group of two or more equations. Now that group could be of two equations, three equations, four equations, and so on and so forth. But for the purpose of our discussion here, we're going to confine ourselves to two equations with two variables. And what are those two variables? The first one is independent variable x, which is plotted on the x-axis, and the other is a dependent variable y, which is plotted on the y-axis. So essentially, we're going to talk about what is the meaning of system of equations with two equations and two variables. So let's take a simple example of a system of linear equations and see what does it mean when we say that we are solving a system of equations, right? So let's say that what you see on the board is a system of linear equations, right? The first equation is y is equal to 2x plus 1, right? We all know, we have seen in the past session that this is nothing but represents a straight line. In fact, we also know that the straight line will have a slope of 2 and a y-intercept of 1. Similarly, the second equation also represents a straight line because the highest degree of x is 1, so it's a linear equation and hence it will represent a straight line. It will have a slope of -1 and a y-intercept of 2. So it's very clear that this combination is nothing but represents two straight lines. Now, when somebody asks us to solve a system of equations, what are they essentially asking? They are essentially asking us to find out the point of intersections of these two straight lines, right? So as we see on the graph here, we have plotted the first line L1, which has a y-intercept of 1 and a slope of 2, right? We have also plotted the second line L2, which has a negative slope of -1 and a y-intercept of 2. We also see that these two lines intersect at this point, right, which is nothing but the solution of the system of equations. So essentially, if somebody is asking you to solve a system of equations or to find the solution of a system of equations, they are essentially asking you to find the point of intersection, right? Now, obviously, there are different mathematical ways of doing that, but before we go to those, I wanted to make sure that we understand what is the meaning when we say solving the system of linear equations, right? Obviously, as we would think, right, it's not always necessary that the two lines will intersect at a point, right? For example, if the two lines are parallel, they will never intersect. It means that they will have no solution. So there will be nuances like this, which we'll talk as we move forward. So let's take another example of a system of linear equations and see what it means to solve this one. So the first function here is y is equal to x plus 1. The second one is 2y is equal to 2x plus 6. Again, this represents a straight line. This also represents a straight line. So we're going to see whether these two lines intersect at any point of time or not. The slope of the first line is 1 because x is essentially 1x plus 1 and the y-intercept of 1. So when we draw the line, it looks like this. Now, when we look at the second line, the second function, 2y is equal to 2x plus 6. As we saw in the previous sessions, right, before we find the slope or the y-intercept of a function, we have to reduce it to the standard form, which is y is equal to mx plus b, right? This is also called as the slope-intercept form because m represents the slope and b represents the y-intercept. Hence, we will have to reduce it down to this form, which essentially means that we have to divide the second line by 2 on both sides, which will give us y is equal to x plus 3. So this is our second line. The slope of the second line is 1 and the y-intercept is 3. And when we plot this line, it looks like this. Now clearly we see that these two lines are parallel, obviously because their slopes are the same, so their steepness is the same, and hence being parallel, they will never intersect. Essentially, they will have no solution. So this system of linear equations has no solution. Let's take yet another example of a system of equations, which is a special case, and let's see how it behaves. So this is our system of equations wherein line L1 is given by y is equal to 2x plus 1, and line L2 is given by 3y is equal to 6x plus 3, right? So the slope of this line 1 is 2 and the y-intercept is 1. And when we plot this line, it comes out like this, right? Now, as we have been doing in the past, let's plot this line. But when we plot the second line, right, it overlaps with this line L1. essentially the line L2 is the same as line L1. So L1 and L2 both overlap on each other, and hence every point of intersection, every point on the line is technically a point of intersection, right? Because the line L2 overlaps on line L1. Hence, in this scenario, in this case, the system of equations will have infinite solutions. So this is a case wherein a system of equations have infinite solutions. This is exactly opposite of the previous case wherein the system of equations had no solution because the lines were parallel. They had no point of intersection, and in this one they have infinite points of intersection because every point on the line is a point of intersection. Now, if we really look at the line 2 a little more closely, and let's say if we divide line L2 on both sides by 3. So 3y divided by 3 is equal to 6x plus 3 divided by 3, which essentially gives us y is equal to 2x plus 1. So we do see that line L2 is nothing but essentially the same as line L1. Even if at the first glance line L2 might be looking different to us, but when we simplify line L2, it is the same as line L1, and hence when we plot these two lines L1 and L2 on the XY graph, they are nothing but the same line, so we get the same line again. Hence, every point on this lines is technically the point of intersection because they are the same lines. Line L2 overlaps on line L1, and in this case, the system of equations has infinite solutions. So let's take a quick look at two special cases, right? So here is a system of equations wherein the two lines L1 and L2 are parallel. We did talk about this a bit earlier, right? So obviously these two lines are parallel, so they're never going to intersect, or essentially there is no solution to this system of equations, right? Let's see how their slopes are related to each other. Obviously the slope of line L1, which is let's say given by M1, is equal to the slope of line L2, which is let's say given by M2. So in this case, when two lines are parallel, their slopes are going to be equal to each other. We talked about this a little bit earlier as well. Let's move on to the other case wherein the two lines L1 and L2 intersect at a point of intersection, right? So this is the point of intersection of L1 and L2. So essentially there is a solution to this system of equations, right? This point of intersection, right? Let's say it is minus 1 comma 3. So minus 1 comma 3 becomes the solution to this system of equations, but at the same time this is a special case because L1 is perpendicular to L2, or in other words, L1 is making an angle of 90 degree with L2, right? So let's see how the slopes of these two lines will be related to each other. In this case, wherein two lines are perpendicular to each other, the product of their individual slopes is equal to minus 1. So if M1 is the slope of line L1 and M2 is the slope of line L2, then M1 times M2 will always be equal to negative 1. Or in other words, if you want to move M2 to the other side, you divide the left side by M2 and the right side by M2, and you get M1 is equal to minus 1 over M2. So this is how the slopes of the two perpendicular lines will be related. Okay, so just to wrap up in this session, we talked about what is a system of linear equations. What does it mean when anybody asks us to solve a system of linear equations, right? What does it mean by solving a system of linear equations? What are the different possibilities which exist, right, when we solve any system of linear equations? Either it could have a unique solution or a unique point of intersection, because its solution of a system of equations is nothing but the point of intersection, right? Either it could be having no solutions, in which case the lines are parallel, they are never going to intersect and hence no solution, or they will have infinite solutions, in which case the two lines are essentially the same. The two lines are overlapping on each other, and hence technically every point on the line becomes the point of intersection. We also talked about the relationship between the slopes of the parallel lines. The slopes of the parallel lines are going to be the same, so M1 is going to be equal to M2 in case of the parallel lines. In case of the perpendicular lines, we saw that the relation between the two slopes M1 and M2 is given by the product of M1 and M2 is equal to negative 1. Right? Now, if anybody asks us to solve the system of equations, we can always plot them on an XY graph and we can see whether they are intersecting or not, and we can answer that question. However, it's not necessary to really graph them every time. There are other mathematical ways in which we can solve the system of linear equations. But before we get into those methods, I wanted to make sure that we understand the big picture. We understand what we are solving for, right? What does it mean when we say we are solving a system of linear equations? So in our next session, we are going to talk about the two methods One is called the substitution, the other is called the elimination. Hopefully you guys liked the video. If you did, please do like and subscribe, and I will see you in the next session.